Hello, welcome back to my channel. In this video, we'll discuss about the structure of cellulose. Let us start from D plus glucose. You know, in glucose, there are 6 carbon atoms 1, 2, 3, 4, 5, 6. First carbon is connected to aldehyde group, and second carbon is connected to OH and H. Third carbon is connected to OH. Fourth carbon is connected to OH. This one is also connected to OHH, and this is CH2OH. One thing you have to remember that in third position you will find OH on the left hand side. This OH is on the left hand side. Other OH groups are on the right hand side. So it is easy to remember the structure of D plus glucose. This is the open structure. Now we have to draw the structure of beta D plus glucose. That is the ring structure. You see, this is the fifth carbon, and there is a oxygen, and this oxygen has a lone pair, and this lone pair will form a bond with this carbonyl carbon, because this carbon is positively charged. When this O will form a bond, this existing double bond will be shifted, and this H will also connected to this O. You see, this is the first carbon. This carbon is written first, and this O is connected to this H, and this OH is on the left hand side, and this H on the right hand side. Then second carbon is connected to OH as shown. Then third carbon contains a OH group on the left hand side and H atom on the right hand side. Then fourth carbon connected to OH and H. Then this C is connected to this O like this. You see, this carbon is number 1 over here, and it is connected to fifth carbon like this, and this is the oxygen atom in between number 1 and number 5 carbon, and number 6 carbon is CH2OH. At number 6 position you will find CH2OH. This is the cyclic structure. Cyclic structure. This cyclic structure can be obtained from D plus glucose by crystallization at 371 Kelvin when hot and saturated aqueous solution of D-glucose unit undergoes crystallization. When this D-glucose unit in hot and saturated aqueous solution is crystallized at 371 Kelvin, cyclic structure of glucose alpha D glucose cyclic structure of D plus glucose unit is formed, that is beta D plus glucose. This is also known as hemiacetal, because this carbon is connected to one OH and one OC group. So this is a hemiacetal. This is also known as anomeric carbon. So D plus glucose unit in hot and saturated aqueous solution at 371 Kelvin undergoes crystallization to give beta D glucose. This is the cyclic structure of D plus glucose. Another cyclic structure of D plus glucose is there, that is alpha D plus glucose, but here we are not going to discuss about alpha D plus glucose. One thing you have to remember, in beta D glucose, the third carbon contains OH group on the left hand side, and in first position also the OH group is on the left hand side. So there are two OH groups on the left hand side at 1 and 3 position. In beta D plus glucose, the OH group, let us draw the Pyrinostructure of beta D plus glucose. This is pyran. To draw the beta D plus glucose, we have to draw a hexagon like this. This is the oxygen atom connected to number 1 and number 5 position. Let it be number 1 and it 5. Then this is 2, 3, 4. CH2OH is at this position, and this is the number 6 carbon, and OH on the left hand side is written at the top and H is written at the bottom. You have to remember, if the OH is on the left hand side, in Pyrinostructure it is written at the top. Number 1 and number 3 carbon atoms contain OH groups on the left hand sides. So at number 3 position, the OH group is also at the top and H at the bottom. Other OH groups are on the right hand sides. So at number 2 position, the OH group is written at the bottom and H at the top. At number 4 position, H is at the top and OH at the bottom. And this OH is connected to CH2 at number 6 position is written over here. So now this is beta D glucopyranose. Beta D plus glucopyranose. Now we have drawn the ring structure of beta D plus glucose as shown, and the OH at third position is at the top, and the OH at the number 1 position is also at the top, and other OH groups are at the bottom positions. Pyranose. This is the cyclic structure. This is the cyclic structure, and this beta D glucose, or you can say beta D plus glucopyranose, is obtained from D plus glucose by crystallization at 371 Kelvin when the solution is hot and saturated aqueous solution. So when hot and saturated aqueous solution of D plus glucose is crystallized at 371 Kelvin, beta D plus glucose is formed. This is the cyclic structure. It is also known as beta D glucopyranose. And you see, this is the Pyrinostructure and this is glucopyranose. There is some similarity, so it is known as beta D plus glucopyranose. In beta D glucose, the OH group at number 1 position is written at the top and H is written at the bottom. In third position, you see OH is written at the top and H is written at the bottom. And other OH groups are written at the bottom positions. So it is easy to remember. Now we have to draw the structure of cellulose. Cellulose is a straight chain polysaccharide composed of beta D glucose units. So these beta D glucose units on polymerization gives cellulose. Beta D glucose units are joined by glycosidic linkage between C1 of one glucose unit and C4 of the next glucose unit. So this is the number 1 position and this is the number 4 position. This is the number 1 position and this is the number 4 position. So 1 position contains OH and H, 4 position also contains H and OH. So OH of first beta D glucose is connected to the 4th carbon of second beta D glucose. You see, let us draw the structure. Let us draw the structure of 1 beta D glucopyranose. You know, this is a hexagon. O is present at this position. This is number 1 carbon, 2, 3, 4, 5. and 5 is connected to CH2H, and H is written at the bottom. Then fourth position contains H and OH at the bottom. Third position contains OH at the top and H at the bottom, and H is present over here and OH is at the bottom in second position. In first position, you see OH is present at the top and H is at the bottom. This is one unit. Let us draw another structure over it. Another beta D glucose, because you will be getting a polymer of beta D glucose. So another beta D glucose unit is drawn over here. This is 1, 2, 3, 4, 5. 5 is connected to CH2OH and H is at the bottom. At number 4 position, you will find H at the top. At number 4 position, you will find H at the top and OH at the bottom. And at number 3 position, OH at the top and H at the bottom. And at number 2 position, H is at the top and OH at the bottom. And at number 1 position, OH at the top and H at the bottom. Now let us connect these two beta D glucose units by glycosidic linkage. You know, glycosidic linkage is drawn like this. This is the glycosidic linkage. When two OH groups are connected, they form a glycosidic linkage. You see, a water molecule will be removed and this O forms a glycosidic linkage. So over here you can get a glycosidic linkage. This is OH, this is OH. This OH will be connected to this H as shown, and this O will form a glycosidic linkage. Now let us draw another structure over it, or you can draw below this structure. You see, this is number 1 position, this is number H, this is number 1 position, number 2 position contains H, OH like this, number 3 OH, H like this, then number 4 is connected to H, OH, and number 5 contains CH2OH and H. You too can make a glycosidic linkage over here. This OH and this H can be removed and this O can form a glycosidic linkage. So you see, there are 3 beta D glucose units connected by glycosidic linkage. This is a polymer, polysaccharide, so other beta D glucose units will be written towards this position, and towards bottom you will also able to write some beta D glucose units. We have only drawn 3 beta D glucose units, but this is a polymer, contains more than 10 beta D glucose units. So other beta D glucose units can be written, but it is not that easy to write all the structures. So let us make a polymer from these 3 structures. Let me rub this part. You see, I am now writing this structure first. You see, this is beta D glucose, OH, OH, H, H, OH, H, and this is number 1 position. This number position is connected to O. this O. Then this is the number 4 position of second beta D glucose units. Number 4 contains a H, number 5 CH2H, at the bottom H, at number 3 OH, H, H, OH, H, and this number 1 position contains a glycosidic linkage. You see, this O is written over here. This O is written over here, and it is connected as it is number 1 position. This must be the number 4 position. This must be number 4. This is 1. This is 4. So this is number 4 position. So let us draw another beta D glucose units. You see, H is written at the top, and at number 3 position OH is at the top and H at the bottom. H, OH, then H. This 5th position contains CH2OH group and H at the bottom, and this OH can be written like a glycosidic linkage, and we have to show this will undergo further polymerization with other beta D glucose units. This OH is written as a glycosidic linkage, and this is number 1 position of these glucose units, so it will be connected to number 4 position of next beta D glucose units. And you see over here, this is OH number 4 position. Number 1 position is connected by glycosidic linkage, so number 4 contains a OH group, and let me rub this OH group, and we have to write a O, and this will be connected to number 1 position of next beta D glucose unit. Let me complete over here. H, HOH at number 3 position. OH is at the top and H at the bottom, and H and this O is connected to another beta D glucose unit. So you are getting cellulose, and you see number 1 position of 1 beta D glucose is connected to number 4 position of second beta D glucose, or you can say C1 C4 linkage. So C1 of 1 unit is connected to C4 of the second beta D glucose by a glycosidic linkage. This is glycosidic linkage. Linkage means bond. This is the structure of cellulose. So let me repeat again. You see, this is D plus glucose. This is the CHO group, and OH group at 3rd position is on the left hand side. Then 5th position contains OH on the right hand side. There are 5 OH groups, 1, 2, 3, 4 and 5, and this is D plus glucose, and the OH at the 3rd position is on the left hand side. Now this is the open structure. Now we have to draw this cyclic structure when this D plus glucose in hot and saturated in aqueous solution undergoes crystallization at 371 Kelvin. 371 Kelvin gives beta D plus glucose. In beta D plus glucose, number 1 carbon contains OH on the left hand side and H atom on the right hand side, and number 1 carbon is connected to number 5 carbon by a oxygen atom in the middle, and this number one carbon is known as anomeric carbon, and this is a hemiacetal because this number one carbon is connected to OH on one side and OC on the other side. So this is a hemiacetal. This is a hemiacetal. You see this carbon is connected to OH group and a OC bond as shown. So this is a hemiacetal. This is the cyclic structure because number one carbon is connected to number 5 carbon by the help of a oxygen atom in the middle, and its melting point is 423 Kelvin. This is beta D plus glucose, and we can draw the Pyrinostructure of this beta D glucose. You see, this is pyron. There are two double bonds, but here we have drawn a hexagon like this, and O is present over here, and this is number one carbon. This is 2, 3, 4, 5, and this is CH2OH, and HOH are connected as shown on the screen. You see, OH on third position is on the top, and at number one position also OH is at the top position, and H atoms on first and third carbon atoms are on the bottom positions, and rest OH groups are on the bottom side. This is beta D plus glucopyranose. Now we have to draw the structure of cellulose. Cellulose is a straight chain polysaccharide composed of beta D glucose units. So we have to draw a polymer of beta D plus glucose. These beta D glucose units are joined by glycosidic linkage. Glycosidic means a O is present between C1 and C4 carbon. C1 of one glucose unit and C4 of the next glucose unit. And you have seen how I have drawn the structure of beta D glucose over here. And one thing you remember, in beta D glucose, OH at 1 and 3 position are written on the upper part of the cyclic Pyrinostructure. OH at 1, 3 are written on the upper part of the cyclic structure. This OH and the OH at number 1 position. That you have to remember, and other OH groups are written on the bottom positions. Thank you for watching the video till the end.